last lecture we have seen uh, what is the basic principle of photochemistry, the electronic transitions, what is meant by singlet, triplet state, what are the allowed and forbidden transitions, and also we have seen the photosensitization reaction. The next point of this topic is Jablonski diagram. So the various electronic excited and de-excitation processes in an organic molecule can be explained by Jablonski diagram. So this diagram explains various electronic excited and de-excited processes in an organic molecule during the reaction. So I have shown here this energy diagram, and in that there is a ground state, S0 state is there, S1, Sn states, and on the right hand side there is a triplet state is there. There are different notations are written in the diagram. So one by one we are going to see what exactly this diagram explain regarding the photochemical reactions and photochemical processes. So actually just I have told you this diagram explain various excited and de-excitation processes which are occurring in the organic molecule during the photochemical reaction. The various processes taking place after a molecule absorbs light energy can be summarized as follow. So when a molecule absorbs a light energy, and actually what happens in the molecule is summarized by use of this Jablonski diagram. The first point is the electronic excitation. Now see here, when the molecule absorbs light energy, so when molecule absorbs light energy, it gets electronically excited and goes from S0 state, so this is the S0 state to next higher energy state, that is S1 state, and or maybe S2, S3 or Sn state. When a molecule absorbs light energy, it gets electronically excited and goes from the ground state energy state, that is S0 to S1 state. If you give excess energy, or if the molecule absorbs excess energy, it may go to S2, S3 or S4, likewise different excited states. However, due to high energy, the molecule may dissociate into atoms. That is, when molecule absorbs more energy, the molecule may dissociate into fragments. So this excitation of electron from this S0 state to S1 state is very rapid, and it takes place within a 10 raised to minus 13 second. So within a fraction of second, the molecule when it absorbs energy, the electron is excited from the ground state S0 state to S1 state. Now second one is an vibrational relaxation step or process. Now see here what happened in this vibrational relaxation. The electronic energy levels, now see here I have shown in the diagram the black lines. So all these are the electronic energy levels. So these electronic energy levels are subdivided into a vibrational energy level. So each electronic energy level is again divided into the vibrational energy levels. So all these lines are nothing but these are the vibrational energy levels. So when a molecule absorbs energy, it excited from lower energy to the higher energy electronic energy levels. So each electronic energy level is divided into a vibrational energy level. The molecules in higher vibrational level in S1 or in Sn state lose energy. They lose energy by collision with another molecule and come to ground state. Come to ground vibrational state, so that process is known as an vibrational relaxation. So in this case, when molecule is excited from lower energy to higher energy state, it goes to suppose a S1 state. So this S1 state contains different vibrational energy levels. So molecule come to the ground state or different energy level. Suppose the molecule is here, now it comes to lower energy state by relaxation process, and that relaxation process is known as an vibrational relaxation, and this relaxation is due to the loss of energy by the collision method or collision process. So this is the second process, that is vibrational relaxation, in which the molecule which is in the excited vibrational state comes to a lower energy state by release of energy by collision with the different molecules. So third one is an internal conversion. It is written in capital I and capital C. IC means internal conversion. I have shown here S2 to S1 or S1 to S0 transition state is known as an internal conversion. Now see in this diagram, this is a pink colored mark is shown here, arrow is here. So the electron which is present in the S1, that is S1 state, comes to lower energy state. So that is known as an internal conversion. Now see here what is written here. The molecule can lose further energy by collision and come to ground state electronic state of S0 by loss of heat. So here the heat, the energy is released in terms of heat, and this is known as non-radiative process. So this internal conversion, that is molecule from higher energy state to lower energy state, when it comes from higher energy to lower energy, it releases some amount of energy in terms of heat. So that process is a non-radiative. There is no any radiation takes place. So there, the energy is released in terms of heat. Therefore, this process is known as an non-radiative process, and it is known as an internal conversion. So in this internal conversion, the electron which is present in the singlet state, it comes to the ground state singlet state. So here also shown here. So the molecule which is present in higher energy state comes to ground lower energy state with the release of heat, and that is known as an internal conversion. So next one is in fluorescence. So when vibrationally relaxed molecules, now see here, vibrationally relaxed molecules in S1 state may lose their energy by emission of radiation. Here is the emission. In the last, that is internal conversion, there is a loss of heat. But now in case of this fluorescence, the molecule comes to ground state by release of energy in terms of radiation of longer wavelength than that of absorbed light. So that emission of radiation of lower wavelength is known as fluorescence. So this radiation process from S1 to S0 is called as an fluorescence. So it continues only as long as the molecule are exposed to light. When the molecule is exposed to light and the process takes place, that is relaxation process takes place, and molecule loses its energy with the emission of radiation, that process is known as fluorescence as long as the molecule is exposed to light. If you off the light, then the fluorescence process gets stopped immediately. So that process of emission of radiation is known as an fluorescence process. Now see here, I have shown this fluorescence process here. So the electrons which are initially present in the higher energy state, they comes to ground state energy state by release of energy in terms of radiation. So this release of energy in terms of radiation is known as an fluorescence. Next one is an inter-system crossing. So here the electronic transition takes place from higher energy to lower energy, but here the singlet multiplicity state is changed. So here the molecule or electron which is present in the singlet state, it goes to triplet state. So the multiplicity of the electron is get changed. So that process is known as an intersystem crossing. Okay, the S1 and T1 transition is, we know that allowed and forbidden transitions in the last lecture we have seen. So when S to T1 transition takes place, that transition state is known as a forbidden transition state. So this S1 to T1 transition is forbidden according to the selection rule we know. However, some of the vibrational levels of S1 state, now see here, some of the vibrational levels of S1 state may have some energy as those of T1. That is, the energy of electrons which are present in the S1 state have the same energy which is in the T1 state. In such cases, the molecule may cross over from S1 to T1 state without any loss or gain of energy. So that crossing of electron from one energy level to another energy level, or change in spin multiplicity of the electron without any loss or gain of electron, that process is known as an intersystem crossing. It takes place from S1 to T1 or T1 to or triplet to singlet. So this process is a forbidden transition. This change of spin of molecule in the excited state without the expense of energy, so it is most important, is known as an intersystem crossing. So what is intersystem crossing? The spin of molecule is get changed in the excited state without any expense of energy. Just I have shown here. So this is nothing but the intersystem crossing, where initially the molecule which is present in the S1, it comes to now in the triplet state. If the energy of electron which is present in the singlet and electron which is present in the triplet, if both have same energy, then this intersystem crossing takes place without any gain or loss of electron. So next one is a phosphorescence. So here in the fluorescence we have seen, when the as long as the molecule is exposed to light, the fluorescence takes place. But in case of phosphorescence, it is reverse one. Now see here, phosphorescence takes place here from if the molecule which is present in triplet, it comes to ground state. So during that relaxation process, if the molecule loses its energy in terms of radiation, so that is known as an phosphorescence. The molecule in T1 state may come to S0 state by emission of radiation, which is called as a phosphorescence. The wavelength of this radiation is longer than that of fluorescence as well as incident light. That is, the wavelength of light which is emitted or which is radiated has more wavelength. More wavelength means lesser energy than the fluorescence and the incident light. This phosphorescence takes place after a time delay but continuous even after the source of light is removed. If we remove the source of light, even though that case also the fluorescence process, that is emission of radiation of molecule, when it relaxes from higher energy to lower energy, that is T1 to S0 state, it releases energy, and that release of energy is continuous even though we stop the light from the source. So this is known as in phosphorescence. The next is photochemical reaction. The T1 state has longer life as the decay back to S0 is slow. So the molecule which is present in triplet state has more life than those which are present in the singlet state. They are most likely to undergo photochemical reactions. So the molecule which are present in the triplet state, they are mostly undergoes photochemical reactions because they have more life than those which are present in the singlet state. So photosensitization, the molecule in triplet state may also transfer their energy to another molecule which gets excited. That is, the molecule in triplet state may transfer their energy to another molecule and that molecule which absorb energy, it is get excited. In the last lecture we have seen this photosensitization process. The molecule in T1 state will come to ground state by non-radiative process. So this is a non-radiative process. So this is the overall the Jablonski diagram. Through Jablonski diagram we can explain different excited and de-excited process. So in the first we have explained electronic transitions, the second vibrational relaxation, internal conversion, there is no change in the spin multiplicity, fluorescence, even though we stop the exposed source of light, even also in that also condition in that condition the emission of radiation is get stopped by that molecule. The next is intersystem crossing, the spin multiplicity of that molecule is get changed when it is get relaxed from higher energy to the lower energy. The phosphorescence process, it has more life than fluorescence. Photochemical reaction, the molecules which are present in the triplet state, they undergo mostly photochemical reactions. And the last one is photosensitization. In that case, the donor gives energy to acceptor, and that process is known as an photosensitization process. So this is what a Jablonski diagram.